Alright, so we are going to look at geometry grade 8 and 9. I'm sorry for the slight tad bit delay. So this is a topic that is very important, and as we get into it, we are going to specifically look at parallel lines within the scope of lines that are parallel, the geometry angles that do exist between parallel lines, and then we'll go and turn our attention to some problems that have to do with that. Okay, now in order to get into this a bit deep, I want to get the assistance of a document that I think is this is the document that I want to refer to, guys. Very important document, this one. Okay, and hopefully you can see it, all right, because it's very important. So I want to specifically look at point. If you look at the table itself, let's go to the first row, second, third, fourth. We've already done the first four statements in this table, and we've related those statements back to the, yeah, we've already looked at the statements there. Let's look at the statement number 5, 6, 7, 8, 9, and 10. Okay, so the first one says, if AB is parallel to CD, then the alternate angles are equal. So I repeat, if AB is parallel to CD, then the alternate angles are equal. That's what the first statement with regards to parallel lines says. Let's look at the second statement. It says, if AB is parallel to CD, then the corresponding, the what angles? The corresponding angles are equal. Okay, the third statement says, if AB is parallel to CD, then the co-interior angles are supplementary. The fourth statement says, if the alternate angles between two lines are equal, then the lines are parallel. The next statement, if the corresponding angles between two lines are equal, then the lines are parallel. Then lastly, if the co-interior angles between two lines are supplementary, then the lines are parallel. Now I want you guys to listen to me and listen to me very well. What I've just read to you is very, very important. I almost feel like this is where the geometry starts losing some people completely, because they fail to understand those basic statements. Guys, in the document that you see in front of you, there are how many statements underneath the heading theorem statement? Just before you get to triangles, there are how many statements? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 statements. All right. And what I have just done, I have looked at the last 6 statements before we get to triangles. The last 6 statements. The first one, which I've read to you, is the one that says if AB is parallel to CD, then the alternate angles are equal. Right? And that's very important. And if you look at the column that says acceptable reason, you will see that the reason that you ought to write whenever you are using that statement is alt angles, and then you're supposed to put a semicolon and follow it with AB is parallel to CD. Where do you get this PDF? Well, this PDF, you can find it. You can go to Google and you can write acceptable reasons, Euclidean geometry. You can see the heading there on my screen. You can go to Google, you can type acceptable reasons, Euclidean geometry, and the PDF or the picture should actually appear as one of your searches as a document, and you can then download it. Right? So I've taken a screenshot of it, that's why I can actually share it with you here. Okay? So what I want to do now is I want to remove this document, because I just wanted for us to look at the last 6 statements before triangles. All right? We have done the first 4 statements, and we've looked at the statement with its reason, and we've even done problems that are related to those statements. If you go to my YouTube channel, you will find the live sessions that I've done on this channel with people discussing Euclidean geometry problems related to straight lines and angles that are lying on intersecting lines. So we've done those angles, but now we need to look at the angles that exist between parallel lines. So that will be the purpose of my live session with you today. So I want to re-look at the statements that I've just gone over with you. The first one says, okay, so we are going to be looking at geometry, of course, for grade 8 and 9s. And may I add that this geometry for grade 8 and 9s is just as important for grade 10s, 11s, and 12s. If you're a grade 10 learner, 11 learner, 12 learner, you're supposed to know these statements like the back of your hand. Hopefully you guys know the back of your hand well. So look at the statement. It says if AB is parallel, this symbol here means parallel. If AB, okay, is parallel to CD, now AB would just be a line segment. which is labeled AB. That's what AB would be. Now they're saying if AB is parallel to CD, right, then the alternate angles, now this word, alternate angles, are equal. This is what basically they mean. Let's say this is line AB and then this is line CD. And let's say that these two lines, they are what? They are parallel. Now this word parallel, this refers to when we have two lines that are opposite each other, but they never touch or meet. They never meet. I like comparing parallel lines to a boy and a girl that are in the same high school. And what do you want as a mother or a parent when you send your child at school? You don't ever want your girl child or your boy child to find themselves in a situation where they are meeting or touching another boy child or a girl child. So parallel lines fulfill that purpose. They ensure that there is a good social distance, all right, and that there's never any point where there's a meet up. So AB is a line segment and CD is a line segment, and both these line segments are what? Are parallel because they never meet. So that's what parallel lines are. Then the alternate, now this word alternate angles, the alternate angles are what? Are equal. So what is an alternate angle? If we draw what we call another line that cuts through these parallel lines, we call this line a transversal line. If we draw that line, what it does, it creates angles. Okay, we have an angle there, we have an angle there, we have an angle there, we have an angle there. So around this point, there are 4 angles. And then here, at this point, there are also 1, 2, 3, 4 angles. So a transversal line creates angles for the parallel lines. And therefore, if we come back to the statement and we ask ourselves, if they are saying if AB is parallel to CD, then the alternate angles are equal. Then we understand that alternate angles must be angles that are in a certain position, angles that are located in a certain position. So when you think of alternate angles, I want you to think of the letter Z. The letter Z, right? And I want you to think of this position specifically. The angle here and the angle there. These two angles would be what we would refer to for the letter Z as alternate angles. The Z shape helps us to locate the position of alternate angles. So this is a well-formed Z, but I want you to note that it could be a not so well-formed Z. Okay, these and this angle would also be referred to as being alternate. So alternate angles are angles that are basically formed by the Z shape. Okay, the position of the angles are basically located by the Z shape. So if we come here to this parallel line and its transversal line, where would the alternate angles be located? This angle and this angle would basically be our alternate angles. Does that make sense, guys? I want you to please, in the comment section, let me know when you are lost and when you are found, and when you are really with me. If you are not, you must indicate. If you are, you must indicate, so that I can know whether to explain or to continue right further. So it's all on you. Hopefully you guys can hear me and I am audible to you. Okay, so I repeat, when lines are parallel and there is a transversal line, alternate angles are simply the angles formed by a Z shape. So for this Z, the proper one, these two angles would be alternate. Okay. Also, for the Z that is funny shaped, this angle and this angle would be alternate angles. Okay, so I hope you guys see what I'm saying. So what is this statement saying? It's saying if AB is parallel to CD, as you see that these lines are parallel, then it stands to reason that the alternate angles are what? The alternate angles are equal. This angle will always be equal to that angle. Take note of the position. This angle, the star, would be equal to this angle where the star is. Also, this angle, the dot, will be equal to that angle, the dot, because their position is of alternate angles. So if AB is parallel to CD, then the alternate angles are equal. So like I said, when you think of alternate angles, you must think of the Z shape, or you could say the N shape, okay, because it would mean this angle and that angle, or it could mean that angle and that angle. Okay, so I hope we are together where that is concerned. Let's look at the next statement. If AB is parallel to CD, then the corresponding angles are equal. I repeat, if AB is parallel to CD, then the corresponding angles are what? Are equal. Now, there's a new word we are being exposed to here, and it is the word corresponding. Okay, now you remember that I said alternate angles has to do with our Z or N shape. We know the position of the angles whenever we are talking about alternate angles. Now, in this scenario, we are talking about corresponding angles. And when we talk about corresponding angles, there's another letter that we need to consider, and that is the letter F. That is our F shape. Okay? And I want to say to you that that F is a funny looking F because it kind of has a cap at the top, if you want to call it that. It's not an F that ends there, but you know, it extends a little bit more than that. Okay, so let's say if we have these parallel lines, we have another transversal line. Okay, our F shape would be on top of this parallel line. Okay, but on top of that parallel line, these two angles are what we refer to as corresponding. I repeat, this line is parallel to that one. So on top of this parallel line. Then on top of that parallel line, we say these two angles are corresponding. And if AB is parallel to CD, in other words, if AB is parallel to CD, as you see AB and parallel and CD are parallel, then it would mean that the corresponding angles on top, on the same side of the line. It must be on the same side of the line when it comes to corresponding angles, because if they are not on the same side of the transversal line, then we cannot say corresponding. We only say corresponding if it's on top on the same side. Then we say that angle on top of that parallel line and that angle on top of that parallel line means these two angles are what? Are equal. Why? Because AB is parallel to CD. Okay, so if it's not on top, the other situation would be bottom of this transversal line, bottom of this parallel line, bottom of this parallel line, bottom of this parallel line. These two angles, bottom, I usually say corresponding angles is bottom, we are equal. Top, we are equal. I repeat, corresponding is bottom, we are equal. Top, we are equal on the same side of the transversal line. Very important. Okay, that is corresponding angles. So if AB is parallel to CD, then the corresponding angles, which angles? The top angles and the bottom angles are what? Are equal. But the condition is that the lines have to be parallel in order for the top and bottom angles to be equal. In the same way, guys, if we look at this side of the transversal line, we have top, we are equal. Top, we are equal. Bottom, we are equal. Top, we are equal, corresponding angles. Bottom, we are equal, corresponding angles. So I hope you understand, guys, that our F shape gives rise to what we refer to as corresponding angles, and they are only equal, those corresponding angles, if the lines are what? Are parallel. Okay, and the reason we use whenever we have to actually state that is we write corresp angles for short, and then we state the lines that are parallel, AB parallel to CD, or whatever those lines are which are parallel. This is our reason that we use whenever we're using corresponding angles. We say corresp angles and then semicolon, we state the lines that are parallel. We don't just write corresponding angles alone, but we write corresponding angles for short, and then we write a semicolon, and then we state the lines that are parallel. Very important to state those lines that are parallel if it is corresponding angles that you have identified being equal. Let's look at the third statement. If AB is parallel to CD, then the co-interior angles, what are we talking about here? Co-interior angles are what? Are supplementary. Whoa, okay. It's a bit of a meal there, so we need to unpack it and understand what are they saying. We are being told if AB is parallel to CD. So in other words, let's just draw parallel lines. Let's say that's AB, that's CD. They are parallel lines. Okay. Okay, then AB is parallel to what? To CD. We are being told if AB is parallel to CD, then the co-interior angles are supplementary. Okay, so if AB is parallel to CD, what in the world are co-interior angles? Now I need you to understand that co-interior angles are the U-shape angles, and their position is simply this. They are the armpits. If you look at your arms and you extend them forward in a parallel sort of like position, you see where your armpits are? Okay, now depending on whether you've washed today or you haven't, your armpits most probably stink like crazy, or they are pleasant to be smelled. These two angles, I call them your armpit angles. Co-interior angles, I refer to them as the armpit angles. What do we know about the armpit angles? If AB is parallel to CD, then the co-interior angles, in other words, the armpit angles, are what? Are supplementary. What does supplementary mean? Supplementary means they add up to 180 degrees. All right? So it's very important, guys, that we understand that. Thank you, Portia. I see you there in the comment section. That's exactly what supplementary means. But the condition is that the lines have to be parallel in order for the co-interior angles to be what? To be supplementary. So this is the position. The U shape gives us an understanding as to where these co-interior angles are situated. So if you look at your parallel lines, where would the U be located? This would be our U, in between. So that means this angle and this angle, when we add these two angles together, they should give us 180 degrees. Okay, on the same side of the transversal line, that's where U is situated. This angle and this angle are what we refer to as co-interior angles. The angles are supplementary as long as the lines that are there are parallel. Also, on this side of the transversal line, on the left side of the transversal line, this angle and this angle would also be adding up to 180 degrees. Why? Because they are situated internal to the parallel lines and they form the U shape as well. All right? So I hope we are clear about that. So they usually refer to fun. Okay, why fun? Because the F shape, as we had explained, has to do with corresponding angles on top of one parallel line, on top of the other. Bottom of one parallel line, bottom of the other. That is corresponding angles, and these angles are what? They are equal as long as the lines are parallel. That's F shape. That has to do with what? Corresponding angles. The statement is if AB is parallel to CD, then the corresponding angles are what? Are equal. Then we have U. U shape. We just spoke about the U shape. And what did we say about the U shape? As long as lines are parallel, these two angles, we refer to them as co-interior. What do we know about them? The two angles, they add up to 180 degrees. Okay, angles are supplementary if the lines are parallel. That's the U shape, co-interior. Then last but not least, our N or our Z shape. This has to do with what kinds of angles? Alternate angles. What do we know about alternate angles? If the lines, guys, are what? Are parallel, then we say the alternate angles are what? Are equal. Okay. And I said there's the nice Z or N, and then there's the funky one. Still, the position of what alternate mean is we should always be sensitive to what that position is. Okay. So I hope that really helps us grasp the basics. Right? And I just want to write here that whenever we write the reason for co-interior angles, we write co-int angles, co, and then int, we write the hyphen, int, right, to show that int means interior, and then we write angles, the symbol, and then we write a semicolon, we state the lines that are parallel, and that is the reason we use. So for co-interior angles, co-int angles, semicolon, AB is parallel to CD. For corresponding angles, we write corresp angles, semicolon, AB is parallel to CD, or whatever those lines are that are parallel. And then for alternate angles, alt angles, semicolon, AB is parallel to CD. We must write the reason as it is stated in that exam guideline or acceptable reason document. And that's exactly how I have written the reasons here, so that we are in tandem with what is stated in the acceptable reason document. Okay, so let us now look at some examples so that we can put to practice what we have just learned and see if we really grasp the concept. Okay, so let's look at some maths gaming challenges. That's what I call them. Maths gaming challenges, because you are, guys, in the channel Maths is a Game. So let's start very basic so that we can get into the swing of things. Here is a diagram. We have A and B, we have C and D, right? We are told the following there. You can see what I have there. I have X and I have 40 degrees. And the question is, find the value of X giving reasons. So what comes to mind? Find the value of X, give reasons. Okay. What is coming to mind? So like I said, I'm going to start very basic, and then as we get familiar with the content, then I'll move to more complex problems. So let's start very basic so that we can hone in the concept and reel it in so that it is sensible and we are good with it. So what do you guys have to say here? What would be the value of X and why? Kasi Lifestyle says 40 degrees. Now the reason, if you are saying 40 degrees, do we all agree in the comment section that it is 40? Everybody in agreement that X is equal to 40 degrees? Okay, thank you guys for the follow. I see the following is happening, but I don't see if too many people are following what we are doing. You're following the creator, the live creator, but are you following what we are doing here? Is Kasi Lifestyle the only person who is saying X is 40 degrees? Everybody else is quite comfortable with Kasi Lifestyle's answer. What is the reason? Okay, Abenati is also saying it's 40. Portia is also saying it's 40. What is the reason, guys? Why would we say X is equal to 40? Now I need you to help me with the reason. Okay, I have 3 people that have said x is equal to 40 degrees. Right, Portia, Cindy, Swan, and Abenati. Let's look at Portia, Cindy, Swan's answer. Portia says corresponding angles in full. Okay, AB parallel to CD. Guys, please take note. Abenati, I see what you said. Okay, and I see what user 7883169 also said. So yes, guys, if we look at the diagram, there is AB, there is CD. These 2 lines are parallel as the symbols suggest. X here, yes, indeed is equal to what? 40 degrees. Why do we say so? Why do we say X is equal to 40 degrees? If you look at the diagram, if we look at the diagram, we can clearly see with the red crayon that our F shape is formed there. And you can see X is on top of this parallel line, 40 is on top of that parallel line there. So we have a on top situation. Okay, and since we have an on top situation, and F is the letter of interest, on top, that means that indeed X is equal to 40 degrees. That's the first thing, which is 100% correct. 2, the reason for saying it is such is also 100% correct. It is corresponding angles, right? And we state the lines that are parallel. AB, yes, indeed, is parallel to CD. And I want to go back to the statement that we had basically alluded to. It said if AB is parallel to CD, then the what? The corresponding angles are what? Are equal. And we did mention that corresponding angles has to do with the F shape, on top, or bottom, as we did indicate with the F shape. So you guys are 100% spot on, and I'm very proud of you guys for giving me the correct answer. Let's move on to the next problem or game challenge. Next one. Okay, next one. Here is a diagram. We want to know what the value of X is, giving an appropriate reason. Okay, let me just tick that and that, because our statement, our reason was 100% correct there. What about this one? The value of X, anyone? And why? Okay, I see what Abenati has written. Okay, what does everybody else have to say? The value of X. Do we agree with what Abenati has said? Do we disagree? Is there anything that we'd like to take away from what Abenati has said? Do you want to add anything to what Abenati has said? Okay, seems like people are very silent there in the comment section. So let us see then. We have lines here, MN and PS, and they are parallel. The value of X here, this is where the X is located, 34 degrees located here. So if we look at those two angles, do they have a relationship? Well, it would seem that if we look at that, okay, the Z shape is formed, okay, because this angle and that angle are in that Z shape. They are in that Z position, all right, the proper Z. So then we can say what about X? Indeed, X is equal to 34 degrees. What is the reason? The reason is, and it's very important that we write the reason correctly, we say alt angles, but we don't end there. We write a semicolon and we state the lines that are parallel. Which lines are parallel, guys? Which lines are parallel? Can we see the lines that are parallel? Okay. MN is parallel to PS. Okay. Thank you so much there, Ronald D. Right. Mtuzula, and psychological. You are very funny, man. Okay. So do we see, guys, the importance? If your reason doesn't have these lines that are parallel, then your reason is incomplete, and therefore you could be actually marked incorrect. So your reason must be full on. It must have the parallel lines stated as well. To just say alternate angles alone is not enough. You must state the lines that are parallel. 3. What is the value of x there? So we have xy, we have za, then 68, we have an angle of x. What is the value of x and y? What is the value of x and y? Okay, Lenatin Duzula says x is equal to 64. And the reason that he says that is co-interior angles. XY is parallel to ZA. Okay, that's what Lenati says. And then he changed his answer and said 68. Abenati says x is 68 as well. Co-interior angles XY parallel to ZA. Okay, so we have two people that are agreeing to the same answer. Right? So does that mean everybody else in the live is saying yes, that's what we believe too? Kasi Lifestyle says 68 as well. User 788316961464119 says 112. Okay, someone with a completely different answer from the masses. The majority is saying 68 and one person is saying 112. The rest are silent. IT Mazinho says 112 co-int angles. Okay. Alright guys, I think at least we've given people a chance to respond. Now let's look at it. So XY and ZA, like I said, are what? Are parallel lines. the angle 68 and the angle x are actually located within the parallel lines and on the same side of the transversal line, which is basically then helping us to understand that, okay, if that is the case, then what letter is being formed here? It is the U shape, okay, the U shape, right? And if we remember, U shape has to do with what type of angles between parallel lines. With the U shape, we know that those angles are co-interior angles. But then now, what do we know about co-interior angles? What kind of angles are those? Those, if lines are parallel, it says, if AB is parallel to CD, then the co-interior angles are what? They are supplementary. What does the word supplementary mean? It means they add up to 180 degrees. So if we come back here, x plus 68 degrees should give us a what? 180 degrees. What's the reason for saying that? Co-int angles. XY is parallel to ZA. So our statement helps us understand that the addition of these two angles gives us 180. Now that we have an equation, we can solve for x. So what do? We transpose the 68 degrees to the right hand side, and the positive 68 changes to negative 68 degrees. Then we subtract the two angles. What's 180 minus 68, guys? 180 minus 68. It gives us what? 112 degrees. So if we then look at what people responded in the comment section, right? Linati, you can see, I hope, your error. Abenati, I hope you can see your error. Interestingly, both of you have Nati in your names. N-A-T-H-I, you have Natis in your name. So we need to work on that. IT, you said 112 co-int angles. And the only problem I would have with your response is that you did not include the parallel lines when you responded. You said co-int angles, and that's not sufficient as a reason to support what you've said. We have to state parallel lines. And maybe you guys are wondering why. The thing is, the statement itself says if AB is parallel to CD. So if those parallel lines weren't there, if AB is parallel to CD, then the co-interior angles are what? Are supplementary. So please guys, make sure that you do state the parallel lines when you write these reasons. You see, for the situation of corresponding angles, I wrote the parallel lines. For the situation of alternate angles, I stated my parallel lines for the reason. And then lastly, for the situation of co-interior angles, I stated my parallel lines. And that's very, very important. Okay, very important. All right. Are we good? So statement x plus 68 is equal to 180, statement reason, and then we obviously do the simplification, and there is our outcome. Okay, I hope that was good. What you might call, you guys got some good mathematical flow from those. Okay, let's look at another one. Okay, Here's another one. This time round, you are being asked to find the value of x, y, and z. You've been given that angle 50 degrees, that's AB, that's CT, and you are being asked to find x, y, and z. Right? So, anyone in the comment section, guys, you are more than welcome to guest request. If you want to request, I will definitely let you in. You can extend an invite, come on through, and then lead me through how I would answer this question. Take a look at it, of course. You can obviously answer in your own capacity, but if you feel confident that you can help us, then we can go ahead and invite you in, and you can come and answer all of these questions for us, right? Yeah. What I love as well is that depending on what your eye can see, you will probably not all go about the same way to finding X, Y, and Z, which is why I want you first and foremost to work on it on your own, work on this on your own, do it. And then after a while, I will invite a few of you to actually come through and let me know how you went about answering the questions. So what I'm going to do is I'm going to switch off the comment section for a little bit. So that I'm going to switch it off so that people can do this without being getting interference from what everybody else is writing. Okay, so take some time, do this, and then after 4 minutes, we'll do it together through someone helping us as to how they did it. Alright, so someone who is in the position to actually help us with answering this. Anyone? Like I said, you guys can come on and guest request if you want, and we can discuss it. Okay, anyone? Because remember, you guys will see it differently. So what I need is, yeah, anyone who would like to actually come on and talk us through it. Okay, because remember, these are lines that are parallel, of course. So I see what Linati Mduzola is saying. It would be nice if Linati, for instance, you could come on if you want. I mean, it's good that you're saying it in the comment section, but come and answer. Come and talk us through everything, not just that one problem. Okay. All right. I see you guys are you are timid. All right. Okay. So y, as you guys have said, indeed, y is equal to 50 degrees. Why is y equal to 50 degrees? Because you can see that this one forms the F shape. And on top of this line, on top of that line, on top, on the same side of the transversal line, those angles are what? Are corresponding angles. So we say y is equal to 50 degrees, and then we say corresp angles, semicolon, AB is parallel to CD. AB is parallel to CD. Okay, and then you can update your diagram so that that 50 degrees is punched into that diagram. It's placed there. And then when we relook at our diagram again, we relook at it having that 50 in that position. Okay, now we want the value of Z or X. What is the relationship that exists between the Y and the X? Or you can look at the Y and the Z. What do you know about Y and Z? What kind of angles are these? Or you could look at the Y and the X. What kind of angles are these? You can start with any. Anyone have any clue in the comment section how we would go about finding either Z or X? Let me give you guys a chance. I'm not going to just tell you. Okay, what do you see? You now have Y. Godfidence in all. Oh wow. I love that. Confidence in all. Straight line angle 180 degrees. So if you look at the relationship between Y, okay, and then user 2934 says angles on a straight line, 100% angles on a straight line. I love that. So both confidence in all and user 293, you guys have a point. Okay, so for instance, the Z and the Y, those two angles, they are lying on a straight line. So from here to there, and from there all the way to there, these are angles that are lying on a straight line. They complete a straight line. You have what Y is, so that means you can find Z. Okay, so we can say, if we want, Y plus Z is equal to 180 degrees. Reason, okay, angles on a STR line. We are using the reason as per the acceptable reason document. Are you with me? Y we know is 50. Z we want to find. So we substitute in the place of Y, because we have it's 50. We substitute in the place of Y 50 degrees plus Z is equal to 180. Then we transpose the 50 degrees. And the 50 degrees becomes negative 50. What's 180 minus 50? 130. So that means the value of Z is equal to 130 degrees. So we go and update our diagram. 130. Make sense? I hope you understand, guys. I hope you understand. Then, what is the value of X? Okay. Now, I see in the comment section, many people are saying a couple of things. Baby Gomes said Z and X are vertically opposite angles. I just pinned his comment there at the top. Do we see a Baby Gomes comment there? She says Z and X are vert-op angles. In other words, they are angles that are vertically opposite. Okay, we learned this in a different live session about when we're doing or we're dealing with angles on a line. So yes, Z and X are indeed vertically opposite angles. Okay, remember, vertically opposite angles are angles formed where two lines intersect. Okay, so that's like X and this angle we call vertically opposite, meaning they are equal. And this angle and that angle, we say they are equal because they are vertically opposite angles. Okay, so I hope you understand that, guys. Now BLXX says, isn't Z a alternate angle? No, BLX. If you are saying Z is an alternate angle, it is an alternate angle with which angle? That's my question to you. If you are saying isn't Z, meaning this angle, an alternate angle, which angle is this here an alternate angle with? It is alternate with which angle? Okay, because remember, this here, the Z and the X, okay, the angles, they are vertically opposite angles. This angle is equal to that angle is equal to that angle. We call these vertically opposite because CD and the transversal line, the two angles that are opposite each other, we say they are vertically opposite angle. Okay, you are losing me completely. Z is an alternate angle with X. No, guys, not even. That's 100% wrong. Okay, remember that the Z we talk about, okay, I mean, I've explained this. Okay? That means you guys are losing the concept. Tsepis and BLX, I don't know where you guys are getting your understanding or knowledge, but your understanding and knowledge is completely wrong. We spoke here I think BLX, you need to come on here. Oh, BLX, you don't even have guest request options. That's a problem. So let me just explain. Alternate angles, the Z shape. Z, it's either alternate angles exist between parallel lines. This angle and that angle, we call them alternate angles. They are the Z shape formed angles. This angle is equal to that angle. The reason will be alternate angles. Or this angle and that angle are equal. We call them alternate angles. So please understand, alternate angles exist between parallel lines. What you are seeing is an angle that's here and an angle that's there. These two angles are not alternate because they do not exist between parallel lines. Please understand that, okay? So these two angles are what we call, if you have two lines intersecting each other, two lines cutting across each other, then they form an X, this angle and that angle are equal. But the reason we say that they are equal is because we say they are vertically opposite angles. And so we say vertically opposite angles are what? Are equal. Right? So please, when you look at angles, you need to identify the right relationship to explain why they are the way that they are. Okay, so I'm saying that there's a Z-shaped relationship between parallel lines, which we call alternate angles. Okay, and they are equal if the lines are parallel. We have an F-shaped relationship, which is on top, bottom, bottom. Those angles are also equal as long as we are talking about the F shape. Then we have the U-shaped relationship that has to do with co-interior angles. And we say that if the lines are parallel, then the co-interior angles, meaning the angles that are formed by the U-shape, the armpit angles, the makwapa angles, we say that those co-interior angles are what? Are supplementary. In other words, they add up to 180 degrees. So these three distinct relationships you need to understand well, right? But besides those, there are situations where we have angles that lie on a straight line. So for instance, that's why when we were looking at y and z, we say we can find the value of z by looking at the relationship that exists between the y and the z. These two angles are angles that lie on a straight line. So that's why we could say after finding y, which is 50 degrees, because of corresponding angles, F-shape, top, on top of this line, on top of this line, on the same side of the transversal line. That's why we could say y is equal to 50. Reason, corresponding angles. And then we state our lines that are parallel. AB is parallel to CD. After finding y, we could find z, because y and z are angles that lie on a straight line. So that's why we could say y, which is 50, plus z is equal to 180. And then we gave our reason, angles on a straight line. Then we substitute in the place of y 50 degrees, plus z is equal to 180. Then we transpose the 50, it becomes negative 50. Then z is equal to 130 degrees. So after finding z, we can update that z is 30. Okay. Someone else maybe who's thinking differently from what I just did could have said the relationship between 50 and x, these two angles, the y and the x, are also angles that lie on which what? On a straight line. You can turn your diagram over. Look at this diagram. The y and the z are lying on a what? On a straight line. So y from here to there, x from there to there, back to this straight line. Those are angles that are lying on a complete straight line. So we could have added y plus x and said y plus x is equal to 180 degrees. And then solve for what? For x. We would still get 30 degrees as well. Okay? So that's why I'm saying there are many ways to getting to the answer, and it all depends on what your eye can see. All right, so that's very, very important. Yes, this is a transversal line. We call this line a transversal line, and then these two, A, B, and C, D, are called parallel lines. Okay, they go in the same direction, but they never meet. I hope it makes sense. So we got z. Z is the 130. What's the value of x? Okay, so we go back to that. Baby Gomes already told us that there's a relationship that exists between z and x, and these two angles are what? They are vertically opposite. So we could say z is equal to x, which is equal to 130 degrees. And our reason could simply be vert op angles equal. Okay. Hello, Aiden. Okay, so that's perfectly fine. We could definitely go that direction as well and get the value of x in that way. Okay. No problem. Okay, and remember, we could use this way if we wanted to, or we could say if we want to find the value of x, we could also say x plus y is equal to 180 degrees, because these two angles are angles that lie on the straight line. And we could solve, give the reason, and get the same value for x, which is 130. So x is equal to what? To 130 degrees, and that's that. Okay. All right. That was a problem and a half. Okay, let's look at another one. And I think I'm gonna look at probably two more, and then I'll call this live a night. Okay. Yeah. I'll call this one. I'll call it a night for now. Okay, let's look at another potential problem. Or let's look at this one as a closing problem, actually. You always join late. Remember, guys, that for those that do join late, and it so happens that they always join a bit later than what they anticipated, you guys know that there is a link in my bio, which is a link to my YouTube channel. All sessions that I do here on the YouTube channel, I mean on the TikTok page, I repost. I repost the things there onto the YouTube channel so that you can rewatch from the beginning when I started till the very end. So don't ever feel like I missed out. You never miss out unless you want to be the one who missed out. Okay, so here we are. Here we are being told to find the value of x. So we are given 3x minus 10 degrees here, 3x minus 10, and then here we are given x plus 50 degrees. And we are told to find the value of x giving reasons. Find x giving reasons. So how do we proceed with this problem? 3x minus 10 degrees. How do we proceed? Okay, Baby Goms has a comment there in the comment section. I'm sure you guys can see it. Baby Goms says 3x minus 10 is equal to x plus 50. Okay, I see what you've written. I'm just curious as to why you wrote what you wrote down. I am curious. Because remember, no reason doesn't make any sense. If there's no reason, then it doesn't hold. You need to have a reason. And I want to know what's the reason. Are you serious? Mam Kwanazi, are you kidding me? Are we like all just on a tip of like, right, having names that are derogatory? I'm like, Mam Kwanazi, is this like the police, the minister, what is it, the police officer in in KZN, the one who's wanting to step down as commissioner in KZN. Is this the wife, Lamkwanas? Right, guys, there's no movement, no one is saying anything, and I'm a bit concerned. Baby Gom is the only one that spoke, but the only thing I want to know from her and anyone else who's seen her comment, there it is, I've pinned it. 3x minus 10 is equal to x plus 50. Is that true? And if so, why? PLX says I've already solved it. Now he's waiting for me to solve it. PLX, if you are saying maybe, then it means you are still not sure. I'm very fearful of people that use maybe, because it means they're not sure. They still want, validation. What is it? It's just what? You're scared? Don't be scared. Don't be scared. Just raise your head. Okay, Portia Cindy, so I just need to approve your comment here because it appears to be filtered. Let me just approve it. There, Portia Cindy so has written out, so Baby Goms was 100% correct in stating what she stated initially. And then what I love is that Portia took it a step further and gave us the reason why, the reason why Baby Goms was 100% in saying that. And then, so we have the statement from Baby Goms, we have the reason with the statement from Portia, accompanied by the working out and the answer. And that's basically what Portia was able to lead out in getting. Okay. Yeah, so 100% beautifully done there, Portia. Okay, so guys, yes, when we look at the diagram, you can see that, key F, all right? And what do you see? It's bottom of this line, bottom of that line on the same side of the transversal line. So that speaks to what? The F shape, and it is what? Corresponding angle. So what do? We say 3x minus 10 is equal to x plus 50. What's the reason? Corresp, as Portia said, angles, and then we state the lines that are parallel. KL is parallel to MN. Portia, I really appreciate you actually taking the time to type this out. I'm sure it must have been quite an exercise to have to type everything like that, but I commend you for it. Nicely done. Then we transpose x values on one side, so when x is transposed, it becomes 3x minus x. Transpose the 10 degrees, the negative 10 becomes plus 10. 3x minus x is 2x. 50 plus 10 gives us 60 degrees. You're amazing, Portia. And then we divide both sides by what? By 2. Then x is equal to 30. So Portia was 100% spot on. Okay. And all the others that basically, so I've gotten it correct. Okay. Very nicely done, Portia. And everybody else that actually made it a point that they gave the statement. Please guys, statement is 100% correct. The reason, remember the reason accompanied by the what? By the parallel lines. Please, corresponding angles, semicolon, you write KL is parallel to MN. Whatever parallel lines are there, you write the appropriate letters. Then you solve the equation. You guys know how to solve the equation. You isolate, please, and then you divide both sides by the coefficient of x, which is 2, and then you get your answer. X is equal to 30 degrees. That wasn't too shabby, was it? Not too bad, was it? Okay. Yeah. This is what I call maths in action. Okay. So we always need to make sure that that is happening. Okay, let's see. Maybe let's do one more before I leave and end this live. At least end the live for what we've done today, because really and truly it was only just a bit of parallel lines that I wanted to do, and then we'll continue with more of parallel lines and more of geometry for grade 9s sometime tomorrow. Okay, because grade 9s as well, we need to keep you in speed and in check so that you guys don't feel like we're completely leaving you behind, or we are not catering to you guys. Okay, but yeah, these are basics for grade 10, 11 and 12. If these basics are intact, you also should be able to move very nicely. Okay, look at this one, look at this diagram. We have PQ, we have AB, all right, we have TS. Okay, and all these lines are parallel to each other. Then we are asked to find X, Y, and Z giving reasons. So yeah, what do you guys suggest or think? So I'm gonna give you some time to do this on your own. All right, I'm going to hide the comment section for a little bit so that people don't get a chance to comment, and I'm going to allow you guys to find X, Y, and Z giving reasons. And your time starts now. Okay, so I think we can go now. We can actually go ahead and answer the questions. So any thoughts from the grand jury? We want X, we want Y, we want Z. So where can we possibly start then? Any thoughts? Any thoughts? Any whatsoever? Yeah, go ahead, VLX. It's a pity that you don't have access to guest request privileges, because you would probably lead it here, you know, give you a chance to lead it, but you don't have guest request privileges, so okay. X, Y, or Z. Okay, I see co-interior angles people are saying, and then confidence is saying, I'm going to guess that X is 150, co-interior, and co-interior some more, right? Okay, so I see you guys all see that there's co-interior. So if you're gonna look at these parallel lines together, these ones, PQ and AB, then of course between those parallel lines we have X and 30 degrees. What shape do they form? Will form the U shape, right? So U shape between parallel lines. So that means X and 130 have what kind of relationships? It means that X plus 30 degrees is equal to what? 108. What's the reason? Co-int angles. Then we state the lines that are parallel. PQ is parallel to AB. As a matter of urgency, we must definitely state that. How many marks do you have so far? Statement, 1 mark, reason. Full reason, the other mark. Then solve for X. X is equal to 180 minus 30 degrees. So it seems like confidence in all was 100% correct in her guessing. Okay, so I'd say you're a good guesser, Miss Confidence there. Very good guess. Yeah, that's if that was a guess and it wasn't a calculated answer. Then after getting X, we can update. X is 150. Okay, now can we find the next and the next? Y or Z? Who's next? And thank you guys for the follows. The follows are very much welcome. Thank you. This channel is growing nicely. Rest assured, Mrs. Chipmunk is very happy about that. So thank you. ZZZ Mike, he says, is Y120. You're asking me still. Me, I want people that will tell me, not ask me. I am the one that asks. You guys tell me. Okay, Z is not 30 degrees, unfortunately. Okay, even though you see Z, all right, the thing is, the parallel line, there's no line that extends all the way. And Z is this entire angle, all right? And so it is not the Z shape that is formed by a parallel line extending out. Z is this whole entire angle, and this whole entire angle is not alternate to this one, so we can't say Z is 30 degrees. So unfortunately, confidence this time around, the guess is incorrect. Portia says Z plus Y plus X, Z plus Y plus X equal to 360 degrees. Angles reflex, Z equal 360 minus less than 120 less than 150 equal to 90. All right, so Portia there has commented, oh, I see. So Portia is saying Y is equal to 120, and then she gave the reason there at the top, co-interior angles AB parallel to TS. So yes, we can find Y, which is the next thing we can find. Okay, so Y plus 60 degrees is equal to 180 degrees. Where are we looking now? We are looking at AB and TS. We are looking at the parallel line AB and TS. So we can see another what? Another U shape. So Y and 60 degrees together, they add up to what? To 180. Reason. Co-int angles, parallel lines, AB parallel to TS. So we have a statement, reason. Then we can solve for Y. So Y is equal to 180 minus 60 degrees. 180 minus 60 is 120. So Y is equal to 120. We go to our diagram, update new information with a pencil, right? Yeah, sorry guys, I'm not updating with a pencil because, of course, X plus Y is equal to Z. No, X plus Y is not equal to Z, can't be, all right? But we can actually use something that someone stated before, and that is what Portia said. Okay, BLX as well alluded to this as well. Okay, yeah, so confidence, what you do see here is that X with Y with Z, all three of these angles, they do something very, very important, and that is they form angles around a what? Around a point. So that's like Z from here to there, then X from here all the way to there, then Y from all the way to there to here. And what you see is a revolution, right? Or in other words, angles around a point. Now, what do we know about angles around a point? They actually add up to who? To 360 degrees. So we are going to say X plus Y plus Z is equal to 360 degrees. What's the reason? Angles around a point. So that's the reason we use whenever we are using angles around a point, meaning the angles around that point add up to 360. Circle, a full circle, 360 degrees, okay? 360 degrees. Another reason we could write is angles in a rev, okay? So please guys, okay, revolution, Portia, not resolution. Revolution, you even said resolution. You need to resolve, Portia, that it's not resolution, it's a revolution. That's a resolve you need to make from within you. Okay, very important you make that resolve very soon. So x here is 150, y is 120, z is what we are looking for. So we transpose everything, 360 minus 150 minus 120 with a z. Then we solve for that. Z is equal to, and I think you guys said it best, that it's 90 degrees. Okay, which in other words, it means Z is a right angle. Okay, and that was that. Statement, reason, okay, and then answer. Guys, please take note that the reasons I have used here are not just freestyled reasons. No, we don't freestyle when we write the reasons. Okay, we write reasons according to the acceptable reason document. Okay, so please, no freestyling, guys. We don't freestyle. We write reasons according to the acceptable reason document. Okay, so always be cautious of that. Okay, right, so I'm gonna call it a night, guys, now, because that is as much as I wanted to do as far as geometry, grade 8 and 9. Parallel lines is officially sort of like something we can bring to a halt. I think one other maybe last concluding thought I want to end on when it comes to parallel lines, and it's these last three statements here, and I want us to look at them. The first one says, if the alternate angles between two lines are equal, then the lines are parallel. This is a grade 8 and 9 concept, guys. Grade 8 and 9. Okay, obviously the grade 8 and 9 concept is needful for your basics in grade 10, 11 and 12. Right, more so when you're in grade 12, because you apply all these concepts in that grade. Right, so grade 12 obviously is the exit grade, but foundational to it is these concepts established in earlier grades. Okay, so this statement says, if the alternate angles between two lines are equal, then the lines are parallel. Okay, so I just want to say this. Let's just check this out. Let's say I came to you and I asked, is AB and CD parallel? What would you say? Does AB and CD look parallel? I ask again. Does AB and CD look parallel? Nita says no. Okay. Now let's say I did this. And I asked the question, is AB and CD parallel? Is AB and CD parallel? Is AB and CD parallel? Nita still says no. Is AB and CD parallel? Okay, user 4003410197430 says yes. Alternate angle equal. Okay. So I want to go back to the statement here. The statement says, if the alternate angles between two lines are equal. Now let's come to this diagram. This is AB. This is CD. And yes, when you look at them, you're like, these lines do not give me parallel vibes at all. But I want you to take a look at the angles that I have. These two angles, what shape do they form? What is the shape that is formed by these two angles? Isn't this the Z shape that is usually formed? Okay, it is. So if this is a Z shape, that means these angles are alternate angles. Angles that are alternate. Now I want to say to you guys that alternate angles are simply angles that are found in this position. Alright, so if I drew a diagram like this, for instance, okay, this angle and this angle are actually alternate angles, whether the lines are parallel or not. We call these two angles alternate because the word alternate has to do with the position of these angles. The angle here, the angle there, the Z-shaped positioned angles. That's what alternate angles are. The Z-shaped positioned angles, right? So that's why this statement says, if the alternate angles between two lines are equal. Now here's the thing. If these alternate angles happen to be equal, then what can we say? We can say then the lines are what? Are parallel. So I'm coming back here and I'm asking again. Is AB and CD parallel? Right? And if you remember, Nita said no, but user 40034 said yes. And his yes was accompanied by the fact that alternate angles equal. So we would say here that AB is parallel to CD in the scenario. Why? The reason is, as user 400 stated, alt angles equal. The alternate angles, the angles that are in the alternate position, they are actually having the same value. They are, in other words, equal. So we have proven that AB is in actual fact parallel to CD, and the reason why that is the case is because alternate angles are equal. So I want to then say to you that sometimes in geometry you get asked to prove that two lines are parallel. You get asked to prove. The question will say, prove that AB is. And whenever that is the situation, there are one of three things that you need to look for. And the first one I've just explained to you. I'm repeating. If the alternate angles between two lines are equal, then the lines are what? Are parallel. So do you remember what I said. I asked you, is AB parallel to CD? Okay. And your response from what you are saying would be no. But the response from what we know, this angle and this angle are alternate angles because of the position of the angles because of Z. So that means these angles are alternate. And as being alternate angles, we can see that the angles are what? Are equal. Therefore, AB and CD must definitely be what? Be parallel lines. What's the reason? Alternate angles are equal. So this is a reason that we use this one. When we want to prove whether lines are parallel or not, we use this reason. Alt angles equal. Okay, let's move on. There's another statement that I want us to look at. This one. If the corresponding angles between two lines are equal, then the lines are parallel. So check me out again. So I'm asking this question. Is BC and NP parallel lines? When you look at them, is BC and NP parallel lines, guys? BC and NP, are they parallel? Okay, definitely no. Thank you so much. I really appreciate you guys answering. So, let me do this now. Now I ask again, is BC and NP parallel lines? Is BC and NP parallel lines? Is BC and NP parallel lines? Okay, it seems like user 400 is getting the understanding behind this. All right, so in this situation now we can see that BC and NP, all right, even though they are lines and they look not parallel, what can we see here? We can see that this one and this one on the same side of the transversal line have on top of this line and on top of this line, these two angles, they are actually what? Equal. So what shape is that on top? That is corresponding angles, right? And these corresponding angles, what do we see about them? These corresponding angles, they are actually what? They are equal. Does that make sense? These corresponding angles, they are in actual fact equal. So what can we say then? Simply put, we can say BC is parallel to what? To NP. Why? Corresponding angles equal. This is where we use this reason. We use it whenever we want to prove that two lines are parallel. If we find that there are two angles that are in the corresponding position, and those two angles are actually equal, then we can conclude that the lines, as we can see here, BC and NP are actually what? Parallel. And the corresponding angles equal comes into play in that very instance when you want to prove that two lines are parallel. The last one I want to do now is this one that says, if the co-interior angles between two lines are supplementary, then the lines are parallel. I repeat, if the what? The co-interior angles between what? Two lines are what? Are supplementary. What does supplementary mean? It means they add up to 180 degrees. Then the lines are parallel. One last scenario. I have DE and FG. And my question then to you guys is DE and FG parallel at first sight? Obviously you will answer no. Then I ask this following question. Is DE and FG parallel now? Is DE and FG parallel? That's 160, that's 20. Is DE and FG parallel now? Yes, Samantha, yes indeed they are. Oh wow, Samantha, hello. Yes indeed they are. Alright. And why would you say they are? So we can say there that DE is parallel to FG. Okay. And what would be our reason? As Nita has said, co-interior angles add up to 180. Right? So our acceptable reason that we use according to the document is we write co-int angles sub co-int angles sub. Okay, yes. So this is very important. Okay, so guys, why this? This is in the document, the acceptable reason document, and probably kids wonder all the time, what reason do we use when we want to prove that lines are parallel? There's one of three things you need to check to prove that lines are parallel. It's either you check or you actually find if whether the alternate angles are equal between those lines that you want to prove are parallel. And then obviously when you do eventually prove that, you then conclude and say AB is parallel to CD and you state the reason alternate angles are equal. Or you check or prove if the angles are corresponding. It can either be on top equal or bottom equal on the same side, or on this side on top equal or bottom equal on the same side. Okay, then when you conclude the lines are parallel and you give the reason angles equal. Or you can either prove that the co-interior angles are supplementary, and when you conclude you say the lines are parallel and you give the acceptable reason. One of three ways to prove that lines are parallel. Okay, so that's the note I want to end on. Okay, so in the live sessions that I will do follow up with the grade 8s and 9s, I'll definitely save this video. We'll be posting it up onto the YouTube channel. The link is in my bio, because I've done part 1, part 2, part 3, and now this will be part 4 of grade 8 and 9 geometry. So you guys need to check those out. If you haven't as of yet checked it out, please go onto the link. It's in my bio. You subscribe to the YouTube channel. You check out the videos that I've done so far. If you're a grade 8 and 9 learner, there are more videos that I've done of live lessons in the platform, so you can check those out. Mrs. Chipmunk will be more than happy to to help you via those videos, so you must check it out. And then also with with the other grades, grade 10, 11, and 12. There's also like recent videos and recent live lessons that I've done with the build up to the trial exams for you guys. So you must check those out and yeah, dive into the maths. And more than anything else, beyond the time that I spend here doing lessons, you guys need to practice the mathematics so that it becomes second nature for you. You need that time, because me doing it is not enough. If you want to get the good marks, it's up to you actually doing your part as well. I was actually happy yesterday because, you know, without me even not realizing, there's actually a learner that came onto the live lesson whilst I was busy yesterday. This is actually yesterday, guys. I want to show you this comment. Sorry, I'm gonna remove the comment section a little bit so that you can see this. These are the things that make me happy, because it makes me realize that for those that are actually coming into my live lessons and they are putting the lessons to good use, there's a lot that they are taking away, and it's impacting their marks. You can see there in the comment section, this was me yesterday doing solutions of triangles for the grade 11s, and a learner came through, Aiden. I don't know Aiden very well, to be honest. It was the first time having a one-on-one sort of like encounter in the comment section, because he commented and said, "Thank you so much, sir. I've watched your lives in term 1 and got 93% in maths. May God bless you." That in and of itself to me is a testament that for those that are joining in and are doing so consistently. But also, guys, more importantly, it's not the magic in the maths that I do, it's the magic in what you then go ahead and do. The sessions will obviously be a catalyst for you so that you can do your part. And then when you go ahead and do your part and you do it well, it should translate, man. It should really translate, and it should affect the way that you are able to perform. So I really appreciated that comment yesterday, very much so. It left me feeling like at least there's a difference that one is making, especially if that learner can actually acknowledge that important aspect. So please, guys, continue. Like I said, do your part. Let it not just be you joining in and that's just it, and you don't do anything with what you've learned here and you leave it like that. That's not how it's supposed to be. Like I said, the sessions are supposed to be a catalyst for you. You guys know what a catalyst is most in physics, and in physics, in chemistry, a catalyst is supposed to speed up a reaction. Yeah, so in the same way, these live lessons are supposed to sort of like accelerate and elevate your personal marks as you do your part and as you go and implement and apply the concepts that you've picked up here. Let it not be you joining in simply so that you can see me and observe me doing the maths, but let it be something that you also take into heart and you apply for yourself. You can get those marks, those big marks, because they are within your reach. Thank you so much, guys. It was really good having you guys join in, and I hope you guys will have a wonderful, great morning further. Until next time, goodbye.